Good evening, everyone, and welcome to the Math 2412 Practice Test 1 review. So this practice test review will follow the same exact pattern as Test 1, and it's the identical questions as the practice test that I've already posted on Canvas. So you may use that as a guide as you work through the problems. So let's get started. Question 1 wants us to find the complement. Now remember, finding the complement is the same as subtracting 90, but I'm not going to use 90. I'm going to use 89 degrees, 59 minutes, and 60 seconds, because that is equivalent to 90 degrees. And from there, I will subtract 77, 56, and 28. And for that, all you do is subtract degrees, subtract minutes, and subtract seconds. So our answer is 12 degrees, 3 minutes, 32 seconds. All right. Question 2 wants us to change from degree, minutes, seconds to decimal. So here's how we do that. It's pretty easy. Calculator does it in one shot. So the first number is 84, so we will write 84. Then we will do plus 14 divide 60, because there are 60 minutes in a degree. And then do plus 56 divided by 3600. The reason is there are 60 seconds in a minute and 60 minutes in a degree, so 3600 seconds in 1 degree. Type it in the calculator exactly like you see it, and we'll get an answer in one shot. And if you round to 3 decimals, the answer is 84.249. Let me write that down. 84.249. Excellent. Question 3. We see that it says that sine is positive and secant is negative, and we want to find out which angle theta is in. Well, sine is positive in quadrant 1 and quadrant 2. So 2 choices there. According to our unit circle, secant is negative in quadrant 2 and quadrant 3. So when I look at our choices, it looks like quadrant 2 is what they have in common. So the answer is quadrant 2. Okay, so question 4. Write cosine 63 degrees as its cofunction. First of all, you have to know that the cofunction of cosine is sine. So our answer involves sine. The second thing you must know is cofunction is the same as complement. And complement means subtract from 90. And 90 minus 63 is 27. So the answer is sine of 27 degrees. Question 5. They want us to find the exact value of cosecant of 150 degrees. So we will need our unit circle. So let's take a look at unit circle. You're not going to find cosecant on the unit circle. What you will find is sine. And sine at 150 degrees is actually 1/2. So that means by default, cosecant at 150 is the reciprocal. It is 2 over 1 or just 2. All right, part B. What is cosecant of 313? Not only is cosecant not on the unit circle, 313 degrees is also not on the unit circle. So we will have to use our calculator, and be sure the calculator is in degree mode. In fact, let me write that down. Degree. Okay, so here's how you get around cosecant. If cosecant is not on there, what you would do is in the calculator, first type 1 divide sine, and then write the angle. And let's see what the calculator has to say about all this. 1 divide sine, 313. The answer to that is negative 1.367. Excellent. Question 6 works the same as question 5. The only thing is, instead of degrees, we have radians. Part A is a unit circle question. So the first step is to find out where 11 pi over 6 is located. And once you do that, look for cosine. It is on there, and if you look on there, it's actually 1/2. Part B would like us to find cosine of 1.91. Now, 1.91 is not on the unit circle, and we have to make sure we change to radian mode. It's a calculator question, but change the calculator into radians. Let's do that. So then after that, just type it in. Cosine 1.91. Negative 0.333. There we go. Question 7. They want us to find the angles where tangent is square root 3 over 3 and express in both degrees and radians. This is all strictly unit circle. It's about reading the unit circle. Okay, so if we go to the unit circle and find out where tangent is square root 3 over 3, we will notice that this occurs at 30 degrees and 210 degrees. You'll also notice at those same locations, the angle in terms of radians is pi over 6 and 7 pi over 6. And that's it for that. All right, question 8. Use a calculator to find secant equals to 3.5. There's no secant, but there is a cosine. So here's what you have to do in the calculator to make this happen. First, you have to do second and cosine. And then, since we're dealing with secant, we have to do 1 divided by 3.5. So first, let's set it to degrees and see what we get. Mode, degree, second, cosine, 1 divide 3.5. That becomes 73.4 degrees. For part B, do the exact same thing, but first, change your mode to radians. Second cosine, 1 divide 3.5. That is 1.281 radians. All right, excellent. And that takes care of the first 8 questions. Number 9, we're given a triangle formed by the coordinates negative 4, 7. All right, the first step to finding this is using Pythagorean theorem. We know x is negative 4. We know y is 7. Let's find r. So Pythagorean theorem means x squared plus y squared equals r squared. Let's plug in everything we know. So we got negative 4 squared plus 7 squared equals r squared. 4 squared is 16. 7 squared is 49. That adds up to 65. And if you square root it, 65 is not a perfect square. So r just becomes square root of 65. All right, excellent. And let me write out the rest here. So y is 7. X is negative 4. Now that we have all of our information, we can find anything we want. First up is sine. Remember, sine is y over r. So the answer to sine is 7 over square root 65. You can rationalize if you want. You don't have to. I won't force you to do that. Now cosecant is sine reciprocal. So cosecant would be square root 65 over 7. All right, cosine is x over r. So that becomes negative 4 over square root 65. And secant is just cosine reciprocal, so that becomes 65 square root over negative 4. Then finally, tangent is y over x, which we already have. That becomes 7 over negative 4. And cotangent is reciprocal of that, so that becomes negative 4 over 7. And that's question 9. Question 10, we're told that sine is equal to negative 5 over 8, and it's located in quadrant 4. Find the other 5 trig functions. All right, let's take a look. Okay, so what we know is sine of theta is equal to negative 5 over 8. And we also know that the formula for sine is y over r. So that's like saying y equals negative 5 and r equals 8. So we have to find x. Excuse me. And that can be done by Pythagorean theorem. So, doing that, we have x squared plus negative 5 squared equals 8 squared. X squared plus 25 equals 64. That means x squared will equal to 39. And x will equal to the square root of 39. And that doesn't break up at all. All right, excellent. Now that we know, in fact, I'll make a little list. X equals square root 39. Now that we know this, let's get our answers. All right, cosine is x over r, if you remember earlier. X we just found out is square root 39. R is 8. That's it for that. Secant is just cosine reciprocal, so that's going to become 8 over square root 39. Tangent is y over x. Y was negative 5. X is square root 39, and that's it for that. Cotangent is just tangent flipped over, so that becomes square root 39 over negative 5. Whoops, nope, no. Put it in the wrong spot. Gotta be careful there. Let me erase that. Let me get the... Whoop. I wanted to put it right here. This is where cotangent is. And cosecant is actually sine flipped over. reciprocal. And since we already know that sine is negative 5 over 8, that means cosecant must be 8 over negative 5. Those are our answers right there. Okay. Question 11. You'll notice we have a right triangle where angle A is 56 degrees and side C is 84 degrees. Part A wants us to find angle B. You'll notice that this is a right triangle, and right triangles mean one angle, in this case C, adds up to 90 degrees. Well, since a triangle always adds up to 180 degrees, then that means A and B together must add up to 90 degrees. So to find angle B, all we have to do is subtract 56 from 90. So 90 minus 56 is 34 degrees, and that's angle B. There we go. All right, side A. There's many ways you can do that. There's more than one answer. But notice this. Here's where angle A is. And notice side A is on the opposite side, and side C is the hypotenuse. So a relation that relates the opposite over hypotenuse, in this case, would be sine. So sine of A, which is 56 degrees, will equal to side A, which we don't know, over side C, which we do know, it's 84. Okay. If we cross multiply, we can get A alone, so A is equal to 84 sine of 56 degrees. And for that, I'm going to let the calculator deal with it. Let's see what they have to say. Make sure you're in degree form, because 56, we have 56 degrees. 84 sine 56. That becomes 69.6. I'll go one decimal. So 69.6. I didn't write units, but anyway, 69.6 units. All right, finding side B. Again, there's many ways you can do this, but if this is a right triangle and you already know two sides, why not just use Pythagorean theorem? That works to that will get the job done. So, writing that out, in this case, it's going to be a squared plus b squared equals c squared. We just learned that a is 69.6. B squared is what we're trying to find out. And c was already given, it's 84. Okay, moving this up. If we get b squared alone, that means it's going to equal to 84 squared minus 69.6 squared. And if you put that in the calculator, let's see what we get. 84 squared minus 69.6 squared. That becomes 2,211.84 equal to b squared. So to find b, we're required to do the square root of that. And if you do, side B is equal to 47.0 units. Excellent. All right, so number 12 is kind of a tricky one. It involves a triangle inside a triangle. And we want to find the height, which is y. Well, if you look at this, we have two triangles. A little triangle, which is on the inside, and a big triangle, which encompasses everything. Let's start with the little triangle. It doesn't matter who we start with, but we got to start with something. All right, so we have a little triangle, 33 degrees. We have x and we have y. Okay. Well, here's the thing. Notice that y is on the opposite side of 33, and x is considered the adjacent side because it's next to 33 degrees and it's not the hypotenuse. The trig relation that relates that is tangent. So we could say that tangent of 33 degrees equals y over x. All right. If we were to cross multiply, we get y alone. So y will equal to x times tangent of 33 degrees. Like so. And then from there, if you put that in the calculator right now, I suggest rounding tangent 33 to 4 decimals. So let's do tangent 33 in the calculator. If you do that, you get y equals 0.6494 and then x. Okay, so good job there. Problem is, we have two variables, so by itself, that doesn't help us. So the next step is to look at the big triangle. So this time the big triangle has an angle of 17 degrees. The opposite side is y, but notice the bottom. It's actually equal to x plus 90. And although x plus 90 looks a little weird there, we can still use tangent to create a relation. Following the same pattern of opposite over adjacent, that means tangent of 17 degrees will equal to the opposite side, which is y, divided by the adjacent side, x plus 90. All right, again, if we cross multiply, that means y will equal to parentheses x plus 90 times tangent of 17. And if you put tangent of 17 in the calculator and round to 4 decimals, you get 0.3057 parentheses x plus 90. All right, again, alone that doesn't help us out. But notice this. Both the blue equation and the red equation are both equal to y. So what we're going to do in the next step is set both equations equal to each other. Let's take a look at that. So what that means is we're going to have 0.6494x equal to 0.3057 x plus 90. Now, I know 0.3057 is kind of a messy number, but it is a number still. And with numbers, you're allowed to distribute, and that's our next step. 0.6494x is equal to 0.3057x plus, let's see, 27.513. Let me get that down. 27.513. And as messy as these figures are, it's just a typical algebra question where we move all the variables to one side to separate x terms with non-x terms, and then divide. So the next step is to subtract 6494 minus 0.3057. So in the next step we get 0.3437 x equals 27.513. And then to get x, the last step is to divide both sides by 0.3437. And that comes out to be divided by 80.0. So pretty good, but we're not asking for x, we're asking for y. But that's okay, we can use x to get there. Remember when we got two equations where y was alone? The first one was y equals 0.6494x, and the second one was y equals 0.3057, parentheses x plus 90. You may use either equation, but I strongly recommend using the first one. Looks much easier. So with that said, y will equal to 0.6494 times x, which we just learned was 80, and we will have an answer. And that answer is 51.95, so I'm going to call it 52.0, round it to one decimal. 52.0. All right, next question. Okay, so we would like to find the distance between two cities that lie on the same longitudinal axis, assuming the radius is 6,400. All right, so here's how the reason this works is because the Earth is round. And let's say the equator is right here. Halifax, Nova Scotia is 45 degrees north. So that means above the equator. So something like here, and that's 45 degrees. Buenos Aires, Argentina is 35 south, and south means below the equator. Well, if Halifax is 45 above and Buenos Aires is 35 below, if you add that up, you get an angle of 80 degrees between the two. Okay. And because they're along the same longitudinal axis and the Earth is round, or roughly spherical, that means we can use the arc length formula. S equals r theta. So let's see what we know. We know the radius is 6,400 kilometers, so we'll start with that. The angle between the two cities we learned is 80 degrees. But before you can stop, there's one little issue. This formula only works with radians. So we have to change degrees into radians. And remember, the way to change degrees into radians is to multiply by pi and divide by 180 degrees. Once you have that, throw all of that in the calculator, and let's see what we get. 6,400 times 80 times pi divided by 180. And for that, we get 8,936 kilometers. Perfect. Question 14. Suppose a pulley has radius 18 centimeters, and it takes a time 3.5 seconds for a belt to move 32 centimeters through the pulley. First, find the linear velocity. Well, one of the easiest ways to do this is to know that the linear velocity is going to be the arc length divided by time. So let's make some labels. Okay, we know r is 18 centimeters. We know time is 3.5 seconds. and we know arc length, S, is 32 centimeters. The reason for that is because the belt is moving around a pulley that is shaped like a circle, because pulleys are shaped like circles, or more or less. All right, let's put that in. So it's going to be 32 divide 3.5. And if we put that in the calculator, we get 9.14 centimeters per second. All right, next is to find the angular velocity of the pulleys. Well, the angular velocity can be rewritten as the arc length divided by time divided by radius. And luckily we have all of that. So arc length is 32, time is 3.5, and radius is 18. And let's see what the calculator is going to say. And that becomes 0.51, and the units are radians per second. So that concludes our Test 1 review. I hope this helps. If you have any questions, please don't hesitate to ask me in class or ask me in the Math Resource Center. Otherwise, good luck on Test 1.